What's going on, everyone? Welcome back to another episode of Crypto Catch Up with me, Benny. Today we're going to be doing an educational video for you on hashing and cryptographic hash functions and how they actually interrelate with cryptocurrencies and why they're so important for blockchain related technologies. So let's get into it. So what is hashing? Well, hashing is essentially mapping of data, any data you like, name, date of birth, a file, a transaction, from an arbitrary size to a fixed size. So you can, upload a video and hash that data, and it could be, many hundreds of megabytes, or it could simply just be, a line of text. It doesn't matter. Essentially, it gives that piece of data, that video, a digital identity, like a fingerprint. And we all know that our fingerprints are unique to us. So it's like a unique identifier. And if you've seen or done any research on this, or you hear people talking about it, they are also known as hash values, hash codes, digests, or even checksums when we talk about hash functions and the outputs of them. So what's an example of a hash function? Well, if you have a look on the screen there, we have John Smith. It goes into that hash function, which is an algorithm, and it gets mapped to the hash of 02. Lisa Smith to 01, Sam Doe to 04, and Sandra D to 02 as well. But why is it red? Well, it's red because John Smith and Sandra D are actually what would be known as a collision, because the input should always render a different output for where the input is different data. And that's one of the key properties that we'll talk about in a moment. So what's some use cases of using hash functions? Why do we need to convert data like this? Well, hash tables, like we just talked about, for fast lookup of data. So if you have, a name, a date of birth, Sam and John, there's lots of Sams and lots of Johns out there, so you have to traverse through all of that data to then get to that point where what we could do is actually concatenate Sam and a date of birth together and then hash that data to get a shorter fixed length size, which makes it a lot faster for a computer to look it up in a database. Caching, very similar in slow media. Duplicate entries, of course. And that's similar to the example that I've used above. So if you have Sam, John, and a date of birth that's similar, well, essentially you can use that hash to determine if there is a duplicate entry there without having to go all the way through, look at Sam, surname, and then the date of birth. File verification, so you can check, which is where this checksum comes in, whether it's been damaged or altered. Password storage, hopefully with a salt, which is a additional piece of information to make it more secure, and that salt should be random, or to protect data, which is where cryptographic hash functions come in. And there it is. So this is why we're here. We want to know about cryptographic hash functions. Well, here's some of the extra requirements a cryptographic hash function must have to be valuable, essentially. And these are mainly security properties. So it must be deterministic. So that means when I have an input of the same type, it renders the same output, which is what we saw before with John and Sandra. They are different inputs. They should never render the same output of 02. It should be uniform. So if you have a large amount of data, it shouldn't just take the first amount of data and hash that. It should take chunks of the data across the full array of data that is available, therefore being uniform. It should be fixed size. So like we talked about, the output of it should be a fixed size. So for example, in SHA-256, which is what Bitcoin uses, the output is 256 bits, which is also 64 char or characters. It's non-invertible, so it's a one-way function, unlike encryption. Encryption is a two-way function because obviously you encrypt it, then you can decrypt it. So with this particular function, in a cryptographic hash function, once you hash it, it should be easy to be able to work out that it's verifiably true, but you shouldn't actually feasibly be able to invert it and reverse engineer it. And that's why SHA-256 or otherwise are so secure, because it would take a supercomputer, hundreds and millions of years to be able to traverse through all the combinations to even find the output, which therefore it would be so computationally expensive, it wouldn't be worth it. It should be collision resistant. So by design, these two kind of inputs should never render that same kind of output. They should actually not ever render that same kind of output. And it should have the avalanche effect. So if you change one bit of data, whether it be a small, input data size or a large input data size, it should effectively change the output drastically, which we're about to have a look at. Now here is a list just off our favorite Wikipedia of unkeyed cryptographic hash functions, and what you'll notice there is down the bottom you've got the SHA. So SHA-256 is what's used in Bitcoin, and if you look at SHA-3, originally known as Kesek or however you may pronounce it, that's actually what Ethereum uses. So before SHA-3 was actually finalized, it was originally known as Kesek, and it has some different block header information. That's what they utilize. So if we just give you a quick example before finishing up, you can see the Fox. If we were to run a 256 cryptographic hash function over that, you would get that digest, that hash value, that hash code, that checksum kind of output. And then we go down and you can notice it in the over that they're changing the actual value over here. So here's being changed, here's being changed, here's being changed. And you'll notice that the actual output is significantly different, which is what we were talking about previously when we talked about the avalanche effect. Alright guys, that is hash functions and cryptographic hash functions. If you have any questions, leave them below. Once again, get in touch with me on my socials. If you would like, please like and subscribe, and I'll be getting more educational content out for you shortly. Cheers.